Yeah, Index is really pushing forward to integrate processes.
Welcome back to MTDCNC. Now, we have a lot of G's here today. We have my OG, Thomas. We're in Germany, which obviously starts with a G. And now we got the G series of Index, which is such an exciting topic to talk about because we have automation on the side, we have gantry loading, we have bar feed like you've maybe never seen before. And then the machine over here, yeah, I'm about to blow your mind with this one. But Thomas and I want to talk to you about flexibility, about multitasking, why it's important to incorporate these into your machine shops as we're all fighting for real estate space and labor shortages and everything else that goes into it. And we must invest into the machines that are going to give us that precision and really that price per part that's going to give us the profitability we need to have success moving forward as we adventure the next 5, 10, 20 years into manufacturing. Thomas, I hope that's a good segue for you. My PhD is not quite on your level, but I'm really happy to be here with you. So let's talk about the importance of multitasking to start.
Well, multitasking is becoming bigger and bigger in the industry. It's basically integrating processes in one machine. So we want to get rid of a sequential manufacturing process, put a lot of technologies in the machine. So from the raw part up to the finished part, completely machined in one machine. So that's basically the principle of multitasking. And with our G series, I think we have a really sharp sword.
All right, Thomas, well, I have to interrupt a little bit, right? Because we talk about multitasking is that buzzword that we hear everywhere, and we know it's important. So we've kind of introduced the importance overall to the audience. So how does Index, the Index specific, help with this multitasking feature to help people succeed? Because I currently see a robot here, a gantry loader here, an incredible bar feed here, and I see 2 turrets, 2 spindles, and a milling head on this other machine.
Well, the basic principle is that we have more tool carriers than anybody else on the market. So we have our milling spindle as well as tool carriers. You can use them for machining, for supporting as a steady or tailstock, and gives you the option as the machine side. But also on the technology side, Index is really pushing forward to integrate processes such as grinding, for example, or gear machining, hobbing, power skiving. So you can get rid of certain other machining steps with this turn mill machine. So that's the complete machining principle here.
Index blew my mind recently, by the way, when it came to the grinding aspect inside the machine down to 2 micron. That was absolutely incredible. Now, another one of your customers told me one time, by adding a second turret, an extra center on your Index with the Index machine, they reduced their existing cycle time by 50% more because now they can do both machining on Op 10 and Op 20. That's part of the concept of this first machine here, right?
Right, that's the G concept of our G family, starting from the 220 up to the 520. Yeah, we have 2 bottom tool carriers as well as the milling spindle. So as soon as you have to support your part with the tailstock or the steady, 1 tool carrier is occupied, then you machine with the milling spindle, and there's 1 tool carrier left to do the backside operation. And with the competitors, all are occupied on the left-hand side or the right-hand side. And that's why really sometimes you can gain 50% of productivity.
Yeah, and those are some of the most fun videos to watch as well, to see those things in action. Let's slide over here to this beautiful yellow area combined with the Index machine. What's going on there?
Well, that's our IX center. So that's our robot solution. We built those in-house. Obviously, the robot is purchased by Fanuc, but everything else, like the palletization system, the layout, especially how the handling should be done, that's all developed in-house.
By Index?
By Index with our new department automation system. Index Automation Systems is a new department that we just started this year.
Congratulations on that, and also that's incredible as well. Let's slide just to our right, but probably the audience's left, and talk about this bar feed. Now, I had the great privilege to speak with you off camera, so I'm excited for the audience on this topic. What's going on with that bar feed? There's some crazy diameters and links on these things,
it's a 6 meter bar feeder, and you can handle up to 120 mils diameter. That's the let through of the machine. And basically we're machining lots and lots of discs over there.
It's fascinating to me to be able to do sizes like that. And we can get bigger, of course, but knowing that one and its capability. Now, gantry loading on the back down there. When I talk about gantry loading a lot of times, Thomas, I think of floor space. If I can do it from the top, oftentimes I'm saving floor space. And it's automated, right? This is the world we're getting into. Is there anything other than those two things, or if we want to elaborate about gantry loading and the system in the back we'd like to convey to the audience?
But gantries are really fast, because usually you don't have to open the door. With the robot system, you open the door, that costs some seconds. So in really it's sensitive, when the part is sensitive to machining time, gantry is the option. However, the robot is more flexible. So it depends on what are the needs of the customer. More flexibility, then I would go for the robot system. If you want to cut the edge in machining time, then the gantry system is the way to go.
Thomas, thank you for educating me on that. I do appreciate it. It'll take me better into the future. But I want to bring this all full circle for the audience as well, because you've mentioned a couple of times, and I'm glad that you highlighted it, about the work that's being done in-house. And German engineering, German precision is also a buzzword for people out there. We know how precise the Germans can be. So to know that we're doing this all in-house, we can walk on the other side and there's what we would call a naked machine. Kind of a fun word, right? But a naked machine, because you're doing it all here. Can we talk more about that?
Yeah, what you see here, when we assemble the machines, the major components, they are made in Germany by Index in-house. So the spindles are completely made in-house, the tool carriers are made in-house, even our live tool holders are made in-house. So our philosophy, everything that's related to the rigidity of the machine, lifetime of the machine, precision of the machine, we try to keep it in-house.
Absolutely perfect, Thomas. I appreciate your time. You have taught me well. You are a good man. When I grow up, I want to be like you for sure.
Come on.
Everyone who's watching, thank you so much for your time. This is Index. I have a great honor and privilege to be here today and share this information with you. I hope you've learned as much as I have. Again, Thomas, you are amazing. Hold on. Where are you going? I have something incredible to show you. So get in here and take a look at these chips and this incredible cutting tool. Have you even seen something machining this big? Some of you I'm sure have, but this is mind-blowing for me. Let's take a look at these chips. Again, I have Thomas with me, and as we're looking at these chips, Thomas, would you mind describing what's going on?
Well, it's a deep drilling process where we drill through the counter spindle. This allows us, we have a larger Z travel. So therefore, we can do a really, really deep drilling over there.
And this is based on the chips, the weight of the chips, the hardness of the chips. This is a hard metal. You're going all the way in here. There's through spindle coolant as well?
Yeah, internal coolant. It's quenched in tempered steel. So quite high mechanical strength that we have to handle here. Therefore, we use the power of the counter spindle because they have the same power, main and counter spindle. Therefore, that's the highest power we can get into the G machine.
I mean, I couldn't have said it better myself. I probably couldn't have said it at all without Thomas, but I had to stop the last video and just let you know what was going on here. One more time, let's get our camera guy to come show this drill through spindle coolant, making powerful chips. You see the two turrets. You see the active milling spindle as well. You see the two spindles on either side. There's just so much going on here. So thank you again. Thank you for tuning in. And we just had to throw this in there, didn't we, Thomas?
Thanks, I appreciate it.
Always a pleasure, my friend. Microphone cheers. Yes, sir. Thank you all for watching.